Hey Trig, this is Mr. Edwards coming to you from my house. I'm trying to record you guys a little video today. I left my normal document camera at school, so I have this little operation here with my backup, and we'll see how it goes. So bear with me. What this video is about, it's called dimensional analysis, and dimensional analysis is a way to convert between units mostly. We can change from square miles to square meters, something like that, but we can also use it to help us solve problems dealing with circular motion, and that's where we are right now with circles. We talked about degrees and radians, and now we can start getting into revolutions and linear speed and angular speed, and dimensional analysis will help us solve any of these problems. There are formulas associated with a lot of this stuff, and I'll give you guys those formulas in our notes, but having this foolproof method of solving these rate problems is going to be helpful for us. So without further ado, let's get into this. So dimensional analysis you may have seen in chemistry before when you're converting between moles and milligrams and density, and you can definitely use it for that. But here in math, we're gonna use it for something a little bit different. It's gonna help us solve these rate problems. Traveling 15 miles per hour, how long will it take to go? I don't know, 100 feet, even something like that. Okay. Seen in chemistry, the way I teach this, I'm gonna teach this as like a river we're trying to get across. And to get across this river, we need stepping stones. You need to step on something to get across. So here's our first one. Let's just try this one. I know a lot of you can do this. You have your own methods, and that's fine, but I do want you to be familiar with how I'm doing these. So when these problems get a little bit tougher and I'm using this method, you're familiar with it. So we're converting 0.005 miles to inches. Now, I don't know my inches to miles conversion. I mean, I could get on Google and look it up. But one of them that I do know can take me from miles to feet, and then definitely we should be able to go from feet to inches. So here's the little river I was talking about. All right, we're starting at 0.005 miles, this treacherous river with piranha and whatever, and we're trying to get to the other side. What we're trying to get to the other side is whatever units we're trying to get into. And then we need stepping stones here, these conversion factors we need to get from one side to the other side. So these two guys right here, these are fractions, but they'll be conversion factors. Okay? So moving on, I guess. I know right here I'm in miles, and I don't want to be in miles. I need miles to cancel. So on my first stepping stone, miles are up here in the numerator. I'm going to have miles be down here in the denominator. Okay? So in 1 mile, my conversion factor now, in 1 mile, there are 5,280 feet. That's going to be my first stepping stone. So that's what I'll put. And we don't need the stepping stone. I mean, it was more for show than anything. But I'm multiplying by that little stepping stone would be 5,200 feet, 80 feet in 1 mile. Now miles would cancel. Those are not there anymore. I would be left in feet. And I don't want to be in feet. I want to be in inches. So we need our second one. Our second one is, well, if I'm in feet in the numerator here, I need feet in the denominator here. And 1 foot, there are 12 inches. We're just multiplying by 1 again. I've talked about this in class a couple times, fancy forms of 1 when we were rationalizing the denominator, but 12 inches is exactly the same as 1 foot. Those are exactly the same. So if I'm dividing them, that's just 1. Anything over itself is 1. And if I'm multiplying by 1, I'm not changing the amount. I'm just changing what units we're looking at. So I'm multiplying by my second stepping stone. Miles cancel with miles. Feet cancel with feet. The only units I have left in my dimensional analysis, we're looking at the units, is just inches. And that's what I want to be. I want to be in inches. So once you get it all set up and everything canceled, the last step is to multiply everything on top and divide by everything on bottom. Well, there isn't anything on bottom in this particular example. 0.005 times 5,280 times 12. Yes, it is 316.8 inches. That's it. That's dimensional analysis. Let's do a couple more examples, 2 exactly to be precise, and then we can move on from there. I'll cut you guys loose. There's a little Google Forms I want you to practice. So it says example 2, a car is traveling 1,250 feet per minute. How many miles per hour is that? Okay, so feet per minute is what I'm in, and I'm trying to get to miles per hour. Per meaning divided by. So I'm going to set up my little problem here. 1,250 feet per every 1 minute. Okay, I'm trying to get to miles per hour. Okay, now we have some choices here. I'm in minutes down here in my denominator. I know I need to be in hours, but I don't want minutes. So my first little stepping stone when I'm multiplying here, I don't want minutes. They're in the denominator. To cancel them, I will have to have minutes in the numerator. Okay, well I know that 60 minutes is exactly the same as 1 hour. So minutes cancel. Now I'm in feet per hour. Okay, I need to get from feet to miles now. It's that same conversion we did a second ago. I know there are 5,280 feet in the denominator. If I want feet to cancel, one's in the numerator, I need to put the next one in the denominator, in 1 mile. Feet cancel. Okay. The units I'm left in are miles on top, hours on bottom. Miles per hour, that's what we're looking for. Okay, so then I'll just get my calculator. I'll multiply everything on top and divide by everything on bottom. 1250 times 60 equals divided by 5,280, and it's just at about 14.2 miles per hour. The car's not going very fast. Okay, last one. Save the toughest one if you want to go that route, if you want to think of it that way, but if we can handle this one, we can handle anything, hopefully. So there's some machine. It can produce rope at a rate of 25 feet every 7 minutes. How many hours was it left on if 200 yards of rope were produced? So 25 feet every 7 minutes. It's left on this machine for a certain amount of time. How long was it left on if it cranked out 200 yards of rope? Okay, so we start with the givens. Given here, in this case, we have two givens. We have the rate part, how much is changing by, and then we have this, how much total. I'm not going to say it doesn't matter, but it's easier for me to think about starting with the most amount of information I have, and that's 25 feet every 7 minutes. So I'm going to write that down. 25, can you see it? Yep. 25 feet every 7 minutes. And I know when I get done, it's saying how many hours will it take for all this to happen. Now something comes up here, okay? Over on this one, I have time in the denominator. Over here, I want hours, time, in the numerator. So what that means is this original rate that I did, this 25 minutes or 25 feet in 7 minutes, it's upside down. Okay, we can change this and say, well, every 7 minutes it cranks out 25 feet, and it says the same thing, just in a better way for us. So in 7 minutes, it can crank out 25 feet of rope. And now I want to know how many hours. Okay, so now let's see. I'm just looking at the problem. I know that it gave me a piece of information in yards. So I think it's going to make sense for me to change feet here into yards. Okay, so my first stepping stone, feet are down here in the denominator. So I'm going to put feet up here in the numerator. Now that little conversion that we should know is that 3 feet is the same as 1 yard. Okay, so now we are in minutes, number of minutes, how many yards. Okay, getting closer. Next, I know I only have hours here. There are no yards whatsoever. So I need to cancel these yards if we want to think of it that way. So just taking the piece of information that I have up here, I can multiply this by 200 yards over 1, just so we can stick to this stepping stone thing, okay? So now yards cancels with yards. Getting closer now, I'm in minutes. The only units I haven't crossed out yet, dimensional analysis, we're looking at the units, are minutes. And I want to be in hours. So I'm actually going to need another conversion here. And that conversion is, well, minutes are on top. I'm going to put 60 minutes in 1 hour. Minutes, canceling with minutes. Nice. The only thing I have left is hours. There was a problem I remember in college I had to do in one of my physics classes. And there's a lot of formulas in these classes. And I could not for the life of me remember this formula I was supposed to use for one of these problems. But all I did was use dimensional analysis. I took what was given to me in the problem, different units, and I canceled them, and I knew what units I was trying to get to. I didn't get it right. Don't get me wrong, this isn't a total happy ending story, but I got a lot of the points just because I kind of worked the formula back from just using dimensional analysis, from using the units. Okay. So now that we're left, we multiply everything on top. Everything on top would be 7 times 3 times 200. And we divide by everything on bottom. Now I'm going to be careful here when I divide by everything on bottom. Divided by, start a parenthesis, 25 times 1 times 1 times 60 times 60. Okay, you could have said something, you could have done it this way too. When I say divide by everything on bottom, divide by 25, divide by 60, divide both of them. That would also be 2.8. What you cannot do, this is has to do with order of operations and what your calculator says, is 4,200 divided by, so I multiply everything on top, and I'm going to divide by 25 times 60. 25 times 60. Your calculator reads this as 4,200 divided by 25 first, and then times that whole thing by 60. But that's not what we want. We want the 25 and the 60 in the denominator both being divided by. So you'll see we get a different answer here. The first two we got were the correct ones. 2.8. Takes about 2.8 hours. It was left on to get that amount of rope. 2.8. Okay? That's it. That's the notes on dimensional analysis. Take a look at that Google form, see what you come up with, do those problems, and we're moving on.